This is a short video showing the completed small mill setup. What we're looking at here is the amalgamator, which is the final part of the grinding circuit and amalgamation device. I'll put mercury into this drum, and hopefully the mercury will amalgamate the gold that has not been amalgamated by the amalgam plate inside of this little homemade launder I made. The black pipe feeding into that comes from the Gibson mill, and the Gibson mill is driven by a 2-horse 120-volt electric motor. It is advertised to be able to grind, I think, 2 tons in a 24-hour period. In my experimenting, I haven't seen anything like that kind of production. Over here you can see the feed dipper. This rotates as the mill rotates and will pick up ore and feed it into the mill. Here is the chute of the bin that has gold ore stored in it. And you can see that a lot of it just looks like dirt and small rocks. It's highly oxidized iron vein material, and the gold is not visible in the rock. It has to be crushed, and then it can be seen when it's concentrated in a gold pan. Now this is the discharge part of the Gibson mill, and you can see these slots that will allow the ground material to come out, and the material will hit these amalgam plates here. We're looking at one, and if you look closely, you can see some mercury, that's droplets of mercury down at the very bottom. The whole plate is coated with mercury, but it isn't looking shiny at this point. It may need to be dressed with more mercury. Here we're looking at a feeder mechanism that will automatically feed material from the bin into the feed hopper for the Gibson feed dipper. The table here is a Deister concentrating table, lab size, and up to this point I've not been able to use it successfully because the ground material is not classified. We have some coarse sand and then some fine sand, and the main problem, I think, is this different classification, size classification, so the table isn't working like it's designed to work. I'll not be using it at this point. I'll just be grinding and amalgamating, and maybe at a later date, if I have mercury in the tailings, I may run the tailings over this table and see if I can get the last little bit of gold. I'm looking at the discharge of the amalgamator. It's a 6-inch pipe. I've got to come up with something that's reasonably sized to have a discharge. I need 4-inch pipe coming out of here. So I'm going to have to get hopefully I'll find a ABS plastic 6-inch to 4-inch reducer, and then I'll come out with 4-inch pipe, and it will discharge onto this little amalgam plate in this container, and then from there the tailings will go on down to a 55-gallon drum. They'll be caught by that, and then the excess water will either be pumped back or just allowed to drain in the tailings pond, which is just a small HDPE lined area. And then I have my 2-inch pipes for tailings discharge here too, and I'll connect them to the discharge of the amalgamator when I get ready to run. So at this point, the discharge from the amalgamator is the next step. When that's complete, I will begin milling, or as the water is acidic, so I'll have to add a little bit of lime to keep my plates clean and shiny, my amalgam plates clean and shiny. And I'll have to check lubrication on the trunnion bearings on the Gibson mill. Try not to over lubricate, and avoid getting oil into the ore. But not let the bearings get hot or run without oil. So that's the little small miners amalgamation mill.